Okay, this is project 3, so I'm going to work on this. And first, we wanted to select the data. Okay, select the data and copy and back to the Excel spreadsheet. What my Excel spreadsheet? Oh. Okay, Excel spreadsheet. So I'm not going to use the exactly the same data, but I just wanted to show you how to do your work. Okay, this is the Excel spreadsheet, and we copy the data from the Word document. Now you can paste back here. Okay, so this is the data we paste. Let's say I change some of the data, like a 302 or something, and 485, 385, 30, 450, 572. So I just change some of the numbers randomly because I don't want to do exactly the same as what I did. The first question is this one. They ask, okay, the question they ask is, develop a scatter chart for the data, treating the national income as independent variable. So national income as independent variable. So what that means is X or Y?
X.
X, okay. When you wanted to put X on the X-axis, so it's supposed to be left or right? If you have two columns,
Left.
To the left, okay. So national income will be column B, and the company's sales will be column C, right? So that's gonna be correct. This is the X and Y. Okay, now you select the data. Okay, select the data and insert a scatter plot. Okay, is that okay? Insert a scatter plot, and I can choose this one. You know, it's just a dot. Okay, it's something looks like this one. Is that okay? You got it? Okay. You know, if you have this one and they ask you to add a trend, last time, remember, so we click on this green cross button on the right hand side here, and then click on that, and then you can select add a trend. Okay, select this little button is called trend line. So it's going to add a trend line. Okay, this is a trend line. You can see this is our dash line, right? This is a trend line. So basically you can see there is a positive relation between these two variables, right? And because they're going upwards. Okay, now you click on the trend line and right click. right click. Okay, make sure you click on the trend line and right click. Format trend line. You format that. Okay, now it's popping up this dialog box, and then you scroll down here. So a display equation on the chart. Display equation on the chart. Okay, you click on that. It will give you the estimate equation. Okay, the little one on the pop-up dialog box, and you can see there is a choice is called the display equation on chart. Okay, now this is the equation you wanted to see here. It's a little bit small, but is okay, the equation here is y equal to 0.5308x, and then you plus 329.17. Okay, this is the equation you got here. I'm going to make it bigger so you can see. Is that right? Yeah. So yours is it could depend on the numbers you changed, but you might get a different one. But this is how you're gonna do that. Okay, so we have next step. Use the Excel regression function to report output and ANOVA table. Develop an appropriate estimate regression equation to predict the company's sales given the national income. What will be the company's sales if national income is 500 million based on the estimate equation? Okay, so this is the second question, question B. Okay, now I'm going to show you how to do regression using the regression function. Okay, so if you look at your Excel file, okay, let me save this one first. Yeah, I don't want to lose that. Okay, so let me save as right. Okay, so we're gonna do regression. Okay, remember, so when you wanted to do regression, first you want to click on data, and you can see if you have a data analysis and or not. So this button on the right hand side, the corner on the top, you make sure that data analysis tab is in there. Okay, if you don't have that one, you click on file here. Okay, click on file. And then you go click on more. Yeah, click on more or something the very bottom. And you click on option. Okay, to go file and click on more or option. Okay, when you click on option, it's going to have a dialog box like this one, right? And then you go add-ins, click on add-in.
So I don't know how to do it.
Okay, so do you have file here?
So I have to click file.
Yeah, file. You don't have file? Home, before home, you have a button is called file. No?
Do I have to open the document or?
You just using your Excel.
On the top, all the way.
Okay.
And then you can put the Excel add-ins.
Oh, okay. Okay.
Then analysis tool. Okay. Check.
Okay, it go option.
Receive. Okay. No.
Yeah, click on add in, and then you will see add in, and you click on go add in, and go, and then you have now you have the add-ins. Click on analysis to pack. If you want to use solver, just click on solver. If you don't, and just use click on analysis to pack. Click on OK, and then you click on data here. You will see you have data analysis. Okay, so basically you do regression and you need to have data analysis tab right here. So now click on data analysis. Okay, the dialog box popping up. And then you select regression. Okay, scroll down and you will see there is a function, it's called regression. Okay, select this one, regression. And click on OK. Okay, now ask you to select y variables. Okay, this is your y on the right, right? On the right is your y range. And x is a column B, which is your x. Okay, this is y. Okay, now make sure you select y. And now you move your cursor to input x range. So national income is going to be your x. Okay, select y and select x, because the first one is label, so it's not number, so you need to click on labels. Okay, so select output option is a new worksheet. Okay, so it's going to give you a new worksheet. Okay, so and also you can choose the residues or residue plots.
Either one or both.
You can choose both, because later on we're gonna have that to ask your residues. Okay, so now you click on OK. Okay, and let me see. Oh, I need to go. This one is the same. Okay, mine is 13. Okay, yeah.
Regression.
I didn't know.
So you select until B13. This is a C13, has to be the same.
The first.
Okay. Yeah, now you have this one. Now you have the summary output, because this is a new output. You can see you create a sheet 2, and that is going to give you this report or the outcome. Okay, is that right? Okay, this is the one we call ANOVA table. Okay. So what we're gonna look at is the meaning is the coefficient for the intercept, and for the this is a 2 is a very important number. So for the coefficient, you can see the coefficient for national income is 0.5308, and this is 329.17. That's your estimate equation, right? So your estimate equation is actually y equal to 0.5308, and then you times the national income. times the national income and plus 329.17. Okay, that's your estimate equation. We want to make this one bigger so you can see. Hmm?
Yeah.
Yeah. Okay, basically that's the estimate equation. Is the estimate equation based on the as the coefficient you from another table. So you can see the estimate equation is the same as the one you got from here, right? So if you got something different, you might have to go back to check what's wrong with it. Okay, the summary output is here. So we're gonna do next one. I wanted to see what they ask. Okay. What will be the company's sales if the national income is 500 million based on the estimate equation? What will be the national sales? The sales is going to be 0.5308 times 500, right? And then you plus 329.17. Okay, that's giving you the estimated result based on this equation. Okay, the sales will be 594.59 cents. Okay, for the national income 500 million increase, that the sales will be 594.6. Okay, so that's the Y is your sales. Okay, now we go on another question. They ask is question 3. How much variation in the sample value of the company's sales is explained by this regression model? So what that means? The sample value of the company's sales explained by regression. Okay, they ask you the estimation, they ask you the R. Okay, R square. Yeah, they ask you this one. Okay. This is question 3. Ask you what is the percentage of the variation is explained by national income. So the sales increases, okay, we can say, okay, 80% of the sales increase is explained by national income increases. That's R squared. And anyone, you have questions? That's good. You know what I mean?
No, can you repeat that?
Okay. You use income to forecast the sales, right?
Yes.
Yes.
Okay, they ask you, how important that income will forecast the sales. Okay. The question 3 is asking you, okay, you based on the R square like a 0.79, around 80% of the sales could be explained by the income increases. Right? Okay, that's R square. So R square is higher is better because your model is better, because that is the indicator to showing that how good is your model fit. So you could tell that 80% of the sales increase is due to the national income increases. And is the overall regression relationship significant at 0.5% level significance? Okay. The overall regression and relationship shape significance is we wanted to look at the F value. Okay, this is what you need to look. You look at the F value and the significance level. Do you think this significance level is lower than 5%? Is that right? Is this one lower than 5%? Huh?
And it's 8.94.
No,
It's the
it is higher.
No, it's we have E dash 0.5. So that means
It's less than
0.00008.
Oh, okay.
Yeah, Excel showing that way. So if they do like E dash 0.5, that means you have to add 5 zeros up 4 zero after the the decimal. Got it. So it's actually lower than 5%. Yeah, the F value is that's the whole regression model is significant. In those cases, that means pretty much this is a good model. This is a good model, right? So that's lower than 5%. Okay. And if so, then test the relationship between the independent variable and the dependent variable at 0.05% level of significance. Okay, now they ask you the relationship between independent variable and dependent variable. Okay, what that asks you? So that means that you have to ask you look at the dependent variable is this one, right? National income. Okay, so you want to look at the p-value for that t statistics. Okay, this is where you need to look. Okay, so the t statistics and the p-value associated with that t statistics is 8.67 E-05. Is that lower than 5%? Yes. Okay, yes. Okay, we have a two-way to remember. So if that 0.05, usually the t statistics around 2, like say 1.96 or 2. If the t statistics or F value is greater than 2, more likely it's going to be lower than 5%. You got it? Yeah, actually it's a 1.96, but we just using 2. If you see the number, okay, t value is higher than 2, more likely the p value associated with that is lower than 5%. Okay. So basically that model is significant that the t value is better, is greater the better, and the p value the smaller the better. Okay, so that's a good model. Okay, or we can conclude that national income is a good independent variable, to forecast the sales. Okay, model question D, show the residual plot using an Excel regression function. Are there any concerns with the residual plots? Okay, what is the residual plots? Is this one, right? Do you have any concerns with the residual plots? How do you know that's a good or not good, right? So the residual plots, you look at this, and basically, most of those dots will along the 0, some going up, some going down, or half of them going up, half of them going down. That's good one. Okay. So if all of the values they go into the top, okay, below above 0, or all of them go below 0, that's not good. Yeah. So there's a residual plus. Look at that. Almost half of them it goes down and some of it goes up. So they have is pretty random, and the mean value is close to 0. So we look at the residual plus, that's indicating that's a good model, right? Okay, so the residual plus is showing that the distribution is along 0, and some of them going above 0, some of below 0, but in general, we confirm that this is a residual plus, suggests that the model is good. Okay, so actually you can see the residual plus was reported and down here, and you can see the residuals, and they have some of them positive, some of them negative. Okay, and I'm going to close this one. Okay, let me see. Huh?
We can see anything.
Oh, you cannot see anything?
Yes, this is possible. I think, not sure about.
I don't know, let's say. Okay, anyway, we already finished that, right?
I have a question, please.
Yeah.
So my first question is, on the question A, it says, does a simple linear regression model appear to be appropriate? Do we have to answer like if this is